for use in the classroom, one of the things I like to take a look at is called expeditions. And the value in these are really, this isn't an Esri product, this is an idea. And it's not our idea. In fact, I think Google Expeditions some 15 years or so ago was maybe one of the first. And several people now, several organizations produce expeditions that are really focused around VR content in the classroom. So I want to start by taking a look at two of these just as samples to help give you a broader context of what we are thinking and doing here. So this is the Expeditions site. This is open and available to anybody that wants to use it. There's only a handful of them up here. But again, it's the idea, it's the concepts. And I think, well, I know many of you that have joined this evening are interested in this concept in your own unique form and fashion. But I'm going to take a look here at one that is fairly basic. And this is a story map. Actually, this is at storymaps.com, but the template is still available to you. In this particular story map, we describe it with a little bit of narrative up front, and then we explain a little bit about what VR looks like in this story map. And this is really designed to be a virtual tour, so it's a very simple, very old use case for VR, but we've situated it in a story map. So we've got a map of the grounds, the facility for this World War I memorial. I did the cheesy cartography thing and just drew arrows on it, but for our purposes, I think it gets the point across. So this is a piece of, what you're actually seeing here is a 360-degree photograph. And I've got a little bit of lag, but I'm going to try to move it around here. So I'm clicking and dragging left to right and right. And because this is a 360 image, I can, if my computer cooperates, pan all the way around. 360 full degrees, plus I can look up. I mean, I can look all the way up and equally all the way down. So for geography instructors in particular, this idea of being able to capture landscapes or events or phenomena without trying to impose, your selection of an image or your selection of the world in an image is really interesting. At least it is to me. With 360 imagery, with 360 photography, one of the interesting things you can do is link them together. So in this case, this little target, I'm going to click on it, and I've just jumped to the top of that tower that we'd previously seen. And now I'm looking down and around. So this is a 360 image. They embed very nicely inside of story maps. And we'll talk a bit more about this in a few minutes, but if you're interested in using VR headsets, it can be beneficial to put a button in your story map to simply pop this image out. And we'll go into that more in a minute. But effectively, this story map follows that same pattern. We go through and we've added some narrative to help describe or contextualize the image. And then students can simply scroll through it. The advantage to the story map in this particular case is that ability to use text alongside the image. Otherwise, you probably don't know what you're looking at. It becomes a pretty picture. The text actually gives us some teeth, if you will. In addition, of course, well, this is a side piece of media. It's the 1926 dedication of it, which obviously wasn't taken in VR, so it helps round out the story well. So that's one story, and that uses one type of what many people would call VR media, and that is a 360 photograph. I want to show you one more of these, and it is on the aircraft carrier USS Midway. This one uses 360 imagery as well, but we've wrapped some other interesting things into it. Again, similar structure and format at the front. Now we've moved into an embed, and this is a special embedded object. This is a 3D object that was generated in scene. That'd be the little scene link you see at the top of the ArcGIS Online navigation. That scene is where this was crafted. And this is not actually hosted in ArcGIS Online. This scene was exported out as a 3D object, and it is hosted on a third-party service, which if you don't need live streaming data, this can be beneficial for speed purposes, if nothing else. And annotations, simple annotations are available with this service. So this is a 3D model that you're seeing in a browser. This, like a 360 image, can be rendered especially effectively inside of a VR headset. And I'll give you a little sample of what that looks like in a moment. So that's a 3D model, that of the Midway, obviously. Taking the same approach where we use a base map and we drop some dots to indicate where either images have been taken or images plus audio links, which are particularly effective, especially if you need multiple modes of learning, right? Students can let the audio run while they're looking at a 360 image, and that works just fine in VR headsets as well. And as I scroll down here, there's one other data type in particular I want you to see. The Midway, by the way, is in San Diego, probably less than a mile from the convention center. So if you happen to come visit us during the user conference, not that we want you leaving the conference, but if you're looking for something interesting to do. So the bridge in this particular case, when I click the button, the bridge has actually been captured also in 3D modeling software. And this is called Matterport. Matterport is not just a 360-degree photograph, but it is actually a model. So you can use an iPhone to capture this information and create these models and make them clickable. I might have just missed that, so we'll see what happens. Lindenwood University, if you've seen any of their presentations, have been using Matterport quite a lot lately to bring 3D objects into student learning. Yeah, I clicked on something and I messed that up. So one thing to note about models versus photographs is that models allow for measurement. They allow for distance measurements, at least distance measurements. So they also are interesting for us because in most cases, models can be imported into the scene viewer, like we saw with the Midway. And then we can do some other interesting things like generate VR experiences out of them. The other interesting thing about models that we can do is that if you are interested or you have students interested in game design, you can bring 3D models into, say, your Unreal or your Unity engine and use that as a part of your game design. So again, this is a Matterport, and I'm going to go ahead and close that. And the last thing I'll mention with respect to both photography and models or model captures is that not only can you capture a 360 photograph, but you can capture a 360-degree video. And it functions just like the photograph does. YouTube is probably the easiest place to see an example of this. You go to YouTube and type 360-degree video or VR video, you'll find a nice collection of content there, some of which actually comes from National Geographic. So with that as a bit of an overview, what I'm hoping we can do is take a little look here at what one of these VR experiences looks like. So this is actually inside of an Oculus headset. This is a VR virtual reality headset. If you can you all still see me? I think you can.
Yes,
okay.
We can see you.
So this is wearing one of these headsets. This is, I think at the time I bought it, it was, I think, $299. I think they might have gone up since then. Typically, these VR headsets also include a hand controller. And the hand controller has various buttons on it and things that allow you to click and navigate around. Okay. But there are two eyepieces inside of the headset, and they act as well, they act as your interface. So here in a second, this is going to launch a browser window with so what you're looking at right now is the Meta browser. So these VR headsets have, regular web browsers in them. And one thing we can do is obviously watch virtual reality content inside of these headsets. So I'm clicking on a button here inside of a story map that has been specially designed to launch the Esri 360 VR experience. So thus far, the experience isn't a lot different than what you're going to get if you're using it on a computer, except the screen is annoyingly curved. Now, that's because we're not yet in immersion mode or immersive mode. And when we use a 360 VR app, you'll notice there's those little white goggles in the center of the screen. As a user, I can click on those goggles, and it should throw my throw my visualization into an immersive mode. So it'll wrap completely around me. So this is what I've just done. I've clicked on the immersion mode. Now, this is very difficult to demonstrate through a webinar and in a two-dimensional presentation. But as you're wearing these Oculus headset, I'm moving my head. I'm no longer moving my mouse or moving my hand controller. I'm literally looking around. The screen's being recorded as I look around. And in this case, we're looking at earthquake data. So that gives you a little bit of an idea of what these things look like when you're actually using them. Again, this is a 360 VR experience, and we're going to spend a little bit of effort talking about what that might do for you or look like. I'm going to hop over the rationale. We can return to it in Q&A if somebody's curious. One thing to note about hardware, particularly VR hardware, is that the ArcGIS 360 VR experience software is a part of ArcGIS Online. That team says we, Esri, specifically support Oculus Quest 1 and Quest 2. We've tested it on other VR headsets, and it's looking pretty good. I have not tested it on all headsets. For example, the Class VR headset, I don't know about. But you can see price points there if you're interested in putting it on your Christmas list. These headsets, and there's an interesting stat there on the home line. That Piper Sandler survey that came out just this fall showed that assume about 26%, 25% of your kids, high school age kids, have access to a headset at home. Now, they probably can't bring them in because in some cases they're going to be attached to their PlayStation or attached to their Nintendo Switch. But they have access to the devices. And of course, some will be also using Quest 2. It is a very common and popular gaming platform. So if we look at this in terms of GIS, the ArcGIS Online Scene Viewer is a logical place to start for creating scenes like we saw early on in the demo with the Oculus, or you see two screenshots here that are using either, these are probably, actually the one on the left was generated in City Engine, the one on the right was generated in Scene, but they've both been outputted to the 360 VR experience. And then some other data formats that we've begun to touch on. For those of you that are interested in the possibility of 360 photography, a couple high-level points here for you. There is a sample of a camera in Insta360 right in the middle of your screen. Cameras like this, like the Insta360 or the Theta, take equirectangular photographs. And in this case, the one labeled raw is an equirectangular photograph. So it is effectively projected information in a similar way that we think about projections in terms of GIS. The image itself is projected, which means that for a normal person to, or a typical person to look at that image, you'll need special software to render the image correctly. Usually what that means is you use a host, an image host that is specifically adapted for 360 images. I think, yeah, so I've used both Memento and Kula. Both of them are fine. Memento is cheaper, but it does not necessarily support Oculus. It will, however, support Google Cardboard if you're still using Cardboard. By the way, Google stopped this program, but the designs are now all open sourced, and you can download the designs and make your own Cardboard. The way these work, by the way, is there's usually a little bit of a Velcro, and you drop your cell phone, your Android or your iPhone, and it sits flat in here. And you close up the box, and then you look through the two eyepieces on the front. And these are designed to kind of similar to the old, was it red, green, or red, blue 3D glasses you'd use at the theater. Anyway, it creates a parallax, and you end up seeing quasi stereo. So 360 images. There probably are other cameras out there. Those are the two that I'm most familiar with. And probably other image hosting services, but again, that's what I'm most familiar with. So we'll kind of jump into the meat of the GIS here. So again, we're working within the Scene Viewer. So I'm going to go ahead and open up a pre-built Scene Viewer app, I hope. And there it goes. So this is actually a Mars layer that's overlaid. I did not make the data, so I cannot guarantee the accuracy of it. It is still loading. My apologies. Part of this is just Zoom. So last spring, I believe, we added an interesting new feature to the Scene Viewer. And what it does is, so we've got a regular scene here. I'm not even sure if I can, yeah, okay, I can move it a little bit. Got a regular scene, Martian scene. And you'll also maybe be familiar with the idea of slides in the Scene Viewer. So I've just clicked on and opened my slide palette. And slides are basically bookmarks. They allow you to control whether layers are on and off, but also positions, scale, things of that sort. You can zoom out and preset some positions, which obviously if you've got something that you specifically want kids to see and not have to hunt around for it, the scenes are a great way to escort them straight to that particular point in your map or your globe. So the thing that's been added, however, is this share button. And specifically at the very bottom, you'll notice that there is a 360 VR experience button. And when I click it, you get a new page, and it's going to say, okay, we're now going to take your scene, and we are also going to be aware of your slides, and we're going to take all that information and package it up. And in fact, in that process of packaging, the 360 VR experience, which will be created, becomes disconnected from the original scene. So I'll say that one more time. The 360 VR experience, once it's created, becomes disconnected from the original scene. You know, this has good and bad, well, good and other value to it, right? If it's disconnected, one thing you might notice on our page is that you can actually download one of these scenes. So you can put it on your desktop and, I don't know, coo to it, look at it, be happy it's there. It's all self-contained. And what has happened is the software has generated several images, snapshots really, of that scene layer at each slide point. So now we are in the 360 VR experience, and I'm going to try to move my Zoom controller here. So this is a 360 experience. Now, I don't know if you're seeing the effect or not, but for starters, this thing is a heck of a lot more responsive than Scene was a moment ago. And this is not because Scene is a problem or it's bad. It's because I have a lot running on this computer right now, especially with the Zoom screen capture going on. These are just images. This is 6 pictures that are stitched together, six degrees of freedom, right? Think of yourself as being at the center of a cube. And as we zoom and pan around, all we're seeing is static screenshots. Now, the interesting thing is that we can use our bookmarks, our slides, and we can jump around to our pre-selected locations. And again, move these things as we want. Now, you might be thinking, okay, you're in a 360 VR experience and you're using it on a desktop. The desktop application has just as much functionality in it and conveys the exact same information that the VR or the Oculus headset will when you're looking at this. The reason the argument goes that people should consider VR in the classroom is because of things like capacity for improved sense of presence, potentially improved sense of understanding of the concepts. Some are arguing that empathy can be impacted. Imagine we're trying to, engage an environmental issue here, something that might already be of interest to kids because it's a local issue they're trying to study, and you can give them a way to become a part of that environment, that ecosystem, as you direct their investigation around it. So this is the VR 360 scene. I'm sorry, the 360 VR experience in a browser. And again, it can be produced by sharing from the scene viewer using that share button. And it looks like I've got a video here too, where you can actually see what it looks like in the Oculus. It should look very familiar at this point. It should be rendering out just like the previous was. Previous example where we were looking at earthquakes. Okay. So a couple quick notes. The 360 experiences can be immersive. They are, I believe, the only file format that we have that is immersive in a VR headset. Again, they are disconnected once they are published. And certainly you want slides because that's how you direct the learner around your scene. And my suggestion is that you label those slides. The labeling on the slides is really the only narrative that you can put into your VR experience at the time that you're creating really at the time you're creating the experience. So you can leave labels and things of that nature on in any given layer, and they will display. The readability on them will vary greatly on the labels of, let's say, a base map or a vector layer that you may have. But the labels on the buttons, the slides, are obviously quite clear and crisp. So if you're thinking, Tom, I don't want to build these things, but I sure would like to see what everybody else is doing, this URL takes you over to the 360 gallery, where you can peruse literally 1,000+ VR experiences. I'm going to quickly address models because it's an interesting capacity in terms of being able to create models. And you can spend money in this space, or you can go on the very low to free end. You can, for example, with a modern cell phone, which I have 3 of them around here and I can't find any of them. With a modern cell phone, you can use Google Street View and you can capture a photosphere. That photosphere can be saved down to your phone or can be pushed to a 360 photography site and then used in your story maps. You don't have to go buy a 360 camera. Mobile apps also run free to expensive. I got a little backwards there, folks. Free to expensive. This device right in the middle is interesting as well. If you are interested in Matterport for collecting and building 3D models, this axis hooks up to your cell phone and it auto rotates to collect all the imagery and produce the models that you want. Also, just like 360 photos, you have to figure out how you want to host them. If you're going to produce a scene, an Esri scene layer, that certainly will be posted in ArcGIS Online with no problem. Sketchfab is also a great destination, and it's free if you're doing modest numbers of models that you're uploading. Then some of the other, so this is really trying to describe how a workflow might look. You capture a model, you create a model, or you download it. You bring it into a desktop software like City Engine. You export it as an Esri scene layer, and it can be posted in ArcGIS Online. So these models, much as our Midway ship, can be great for adding value to your scene. A couple of examples of mobile phone apps. The 2 on the left are free, at least if you have modest usage of them. The one on the right does have a price tag on it. It's also worth noting that models on your phone are either generated using photogrammetry or LiDAR. Only some of the newest iPhones support LiDAR, and I believe those are only the Pro models right now. So there seems to be a lot of interest in development in and around LiDAR support because it's also tied to another type of reality called augmented reality, as well as the LiDAR images. The LiDAR data is used to help improve image taking. So again, in this example, I've got a 3D model on the left that I've taken in an iPhone app. I brought it over into City Engine in the middle, and my model is very tiny. It's at the end of that arrow. And then on the far right, you can see an example of that scene being displayed back in Scene Viewer. So it becomes a full workflow. And if I wanted to, then we could take that Scene Viewer and move it into the VR experience. The 2 QR codes will give you both an example of the raw model that's been collected and then how that model is positioned inside the scene. We'll hop over a bit of that. 360 experiences. We've been talking about this all along, but it's the concept of when you're generating these models, when you're generating this photography, what do you do with it? How do you present it to students? And one of the simplest ways to do it right now, given the tools we have available, is to put that content in a story map template. Because you can provide the context because you can provide the additional links to support things like an Oculus headset. It truly does allow for a glue to bring all these various media types together. So that's what we saw in the expeditions, and that's why we started with them. The expeditions are really my best example of how we can blend all these different types of media into producing a set of VR-based resources for learners. So that's what I have.